So very good evening to one and all. So thank you for your joining. So I'm audible to you. If my voice is clear, if my voice is clear means just put yes in chat box. So very good evening to one and all. Thank you for joining. If my voice is clear, means just put yes in chat box. So very good evening to Suja, Bharat. So sir, days 12 attendance. So you will get today. So our coordinator will post the link. Will post the attendance link in chat box. Don't worry that you will get the day 12 attendance link. So Sri Krishna, very good evening. Thank you for your presence daily. So Vaishnavi P, very good evening. So Venkata, very good evening. So thank you for your joining. Thank you for your presence in this 30-day masterclass on advanced VLSI design and verification. Sahaja, very good evening. Yes, sir. Thank you for response. So let's wait for few minutes. So let's wait for remaining people. So we will start at 7:05 sharply. So today we are gonna see assertion. So it is very important topic. So it is only for verification purpose. So we will give some conditions whether it is triggered or not. We will check that. So we will give some condition for design code. If it is satisfied means we can proceed with further things. So this is assertion meaning. So we will see the assertion today. It is also very important for verification, assertion, coverage, and then constraints. These are the very important topics of SystemVerilog for verification. So and then Condelwell. So very good evening. So very critical name to pronounce. So basically I'm from south, so I can't read fluently some North Indians like names. So very good evening to one and all. Thank you for your joining. So let's wait for a few more minutes. So last class we seen like classes, how to create a memory for classes and test bench architecture, task and function, virtual classes. Like we seen lot of things in the last class. So today we are gonna see assertion, and then tomorrow we are gonna see protocol. It is a mini project. So UART is one main basic protocol which is used to communicate with the hardware like a chip to peripheral devices. It's a like a off chip protocol. I already said no. There are two kinds of protocols: off chip, on chip. UART comes under the off chip protocol, and then APP, I2, APP, AXI, that kind of protocols comes under the on chip protocol. So okay. So SK, very good evening. So thank you for your joining. So we'll start at 7:05. So in this today we are going to see assertion. So it is very important thing for verification. So why it is important means, so you can pass the stimulus to design code. So main thing of, so what is a verification in SystemVerilog means, we have some design code, design logic, design circuit. We have to verify that some passing some stimulus from test bench. So we can do randomization in test bench. We can control the randomization, and then we can't do whether it is our randomized test stimulus is working perfectly or not. So you have to, if you want to check the stimulus is working correctly or not, means you can use you can use the assertion. By using the assertion, you can check the stimulus is working perfectly or not. And also it is mostly used for to test the design. So if this particular design is working perfectly or not. So we will give some inputs like conditions. For example, if the assume like two signals A and B. Okay, in the first passage A should be high, then only B signal will get the input. Okay, will get the some values. It's like a basic example for assertion. So A and B are both depends on clock inputs. So it is depends on passage of clock inputs. Okay, in the fifth clock pulse, in the fifth passage of clock, A should be high, If the A should be high means then only B should be work or B should be high. So this is a condition. So in the fifth clock pulse, in the fifth passage, A should be high. Okay. After that A high, then only B will get the value or B will do some work. So this is a condition. So how we can check means by using this assertion we can check the functionalities. Okay. So this is a basic information, basic idea of the assertion. Okay. I hope it's clear for you. So very good evening to Narayana Murthy, Muhammad Tawfiq. So started session was conductor not. So there is no classes in Saturday. So last class Saturday there is no class. So in now upcoming Saturday we will take classes on Saturday. But last Saturday there is some technical issue in my side. That's why there is no class. So attendance link. So we will get the link. Okay. So very good evening to Ganga Devi, Narayana Murthy SK. So I think we'll start the session now. So assertion. So what are the assertions? So an assertion is a statement about your design that you expect to be true always. So in your design you have some critical signals. That signal must be true on that particular time. So there is some conditions, there is some scenarios that particular signal must be true on the particular conditions. So if you want to check that scenario means you have to use this assertion. Okay, by using the assertion only you can check that scenarios correctly. Okay, so it is the main purpose of assertion is validate the design behavior and catch bugs early. So by using this assertion you can validate the design and also you will catch the bugs early. Without implementing the hardware you can easily solve the errors, and then you can easily find the bugs in your design code. Okay. So and then the benefits are improved observability and then better debugging capabilities. So debugging is nothing but, so I'm for example I will take one example. So in the fifth passage, in the fifth passage of clock, A signal must be high. Okay. So this is my condition in the fifth passage of clock. While we know that clock after starting the simulation the clock will be toggling, so you will get the continuously passage of clock. In that at the particular fifth passage of clock the A signal must be high. So it means on the particular fifth passage of clock the A signal must be receive the high value from the input side. Okay, this is a condition. So if you want to check this condition means you can't check in writing stimulus, so you have to use the assertion to check these functionalities. This is the assertion. So we can check the some critical functionalities, critical logics in your design code by using the test bench or by using the assertion writing. Okay, so assertion is very important topic. So we'll see today. So this is the main purpose of assertion. Okay, so it will be benefits of assertion is improved observability, better debugging capabilities, enhanced documentation, and then it is mostly used for formal verification support. Okay. So like there's another definition for assertion. If a property that is being checked for in simulation does not behave the way we expect it to, assertion fails. So if it is we are expecting some things from the design code, if it is not doing so, if it is not working based on our expectation means it is assertion fails. So we can write some assertion. So if it is works what we accept means our assertion is passed. If it is not work what we accepting means it is known as it's like our assertion fails. Okay. So if a property that is forbidden from happening in a design happens during simulation, assertion fails. So forbidden means so it will do some unknown values, it will do unknown operation, it will give unknown outputs means, and that time also our assertion will fails. Okay, this is the conditions of assertion fails. So if we accepted output from design code, if it is gives means so okay it's fine, working correctly, our assertion is passed, or we have tried some condition assertion. So I will tell you that what is the syntax for assertion, how to write the assertion in the SystemVerilog. The main thing is what we accepting. If you get that output means our assertion will pass. If you're not getting that means your assertion is failed. So this is a basic definition working of assertion. Okay. So and then, so if you guys are really interested in this masterclass, you can convert into 1 month of internship. So I already know that. So these are the benefits you will get at the end of the internship program. All that it is recording session, all that it is PPTs you can download also, and then you will get the source codes you can download also, and then you will get the 4+ exclusive projects from the off-chip protocol and also on-chip protocol, and then you will get the internship certificate from the IETE, and then you will get the literally 6 months of LMS course access. It is a recorded sessions. You will get the access for 6 months. So and then we are providing weekly sessions for 1 month. So and then you will get also internship report. Okay, academic internship report. So these benefits you will get from just 999. So there is a link for the application for registration link or registration link for internship program. So and then this is a limited time period offer. By using this link you can get. So and then this is a UI window. After clicking the registration link, here in the domain you have to choose advanced VLSI design and verification. Then only you will get our internship program from advanced VLSI design and verification. Okay, so this is a sample certificate you will get the at the end of the 1 month internship. So if you guys are really interested in this masterclass, you can convert into 1 month of internship. I hope you people are aware it. Okay, so let's enter into the content. So we'll see this. We seen definitions. So and then let's move into learning objective. So definition already we seen that assertion definition. So an assertion is a statement about your design that you accept to be true always. So you are expecting some output from design code. If it is gives means our assertion will pass. If it is not giving what you expecting output means our assertion is failed. Okay, this is a basic definition for assertion. So and then for example, and I already said no previously, at the 5th passage the signal A having high means, so we can say that our assertion is passed. But if the assertion the signal A having 0 at the 5th passage, it means our assertion is failed. So this is how we can check whether it's passed or failed assertion. Basically it is literally some logic for your design code. Okay, we can say like that we are checking the logic of design code. We can also say like this also, we can check we are checking our logic, design logic by using the assertion. This is a very simple way of assertion definition. Okay, so and then it having two types of assertion. One is immediate assertion, another one is a concurrent assertion. So immediate assertion is a non-temporal, evaluated immediately. So there is no clock needed for this assertion, and then it's like work based on the if-else statements. So we know that if condition having true, if it is true means it will execute. If it is false means false means it will execute the else condition. Okay, this is how working of if else. Same like it will work based on the if else condition. What this means, immediate assertion, it is work based on the if else logic. So this is a syntax for the if else assert. So this is a syntax for the immediate assertion. So assert is a keyword. So assert is a SystemVerilog keyword. This is a assert keyword. Here you have to give assertion. Expression. So expression means we can give some logical expression, a equal to 1, b equal to 1 kind of thing. So we have to give the signal expression here. If it is true means there is no error. If it is false means it will execute the else block. Here you have to give action like a error statement, fatal error, or warning. We can write any statements in here in the action side. Okay, so and then coming to the concurrent assertion. So concurrent assertion is nothing but here it will use the clock. It is depends on clock, and then it is mostly used for complex logic. So it is mostly used for protocol check. So already said no, we having the number of protocols, off-chip protocol, on-chip protocol, whether Ethernet is also one protocol, and then Wi-Fi also one protocol, and then USB 3.2 3.1 is also one protocol. So these are the complex protocols we are using currently. So for that concurrent, so it will that kind of high speed protocols like USB, PCI, Ethernet, it will use clock more fastly, it will use high frequency of clock. So on that time you have to use these concurrent assertions. Okay, to check the logic means you have to use this concurrent assertion. These immediate assertions are mostly used for combinational logic. These concurrent assertions are mostly used for sequential logic. Okay, so and then this is a difference between the immediate assertion and the concurrent assertion. So we know that immediate means it won't need a clock, concurrent needs a clock to check the functionalities. The syntax for this assertion, so syntax for the concurrent assertion is look like this only. So assert, here some property, so we'll see one by one what is a property, what is sequence, so what is assert. So the main definition of assert is one keyword. So it having the two sides. If it is true means it won't it will allow to execute next one. If it is assert fails means you will get the fatal error or error message. This is a working of assert. Okay, so here you can see here at passage of clock property underscore expr, it means this is one property block. So we will see one by one what is property block, sequence blank. So there are a lot of topics in SystemVerilog assertion. Why? Because of SystemVerilog assertion, if you want to read means it will take up to 1 week or 1.5 week to learn the SystemVerilog assertion. So and then the main thing is learning SystemVerilog within 1 month is it's a little bit difficult. Why? Because of there are a lot of topics. Why? Because of we having the data types, new syntax, we having the SystemVerilog architectural, and then we having the assertion, we having the constraint, we having the coverages. So each and every topic like a constraint, coverage, assertion is a very huge topic, mostly used for verification purpose only. So it will take some time to understand all these topics, and then it will take some time to you have to practice while you have to write the code, then only you can easily understand. Okay, so this is a syntax for the concurrent assertion. So assert property, so always passage of clock, and then property name, this is a property name. So I will show you the syntax of the property. So this is a difference between the immediate assertion and concurrent assertion. Okay, so you can see a syntax, this is syntax: assert, expression, else, action block, assert, property, always at passage of clock. This is the difference between the syntax. And then reset handling, no built-in reset handling. Here it having the built-in reset, like disable if this one functionalities in concurrent assertion. And then use cases, so immediate assertions are mostly used for simple conventional checks and then error condition, but the concurrent assertion are mostly used for protocol checking, sequence verification, and then state machine. State machine is nothing but FSM. Okay, so tomorrow we'll see the UART FSM. So UART protocol, tomorrow we are gonna see the UART state frame format, UART protocol that's transmitting, so data transmitting like a transmitter receiver side. So we'll see tomorrow UART protocol, and then we will see the whole test bench architecture for UART protocol tomorrow session. So and then complexity level simple, so its concurrent assertion is very high, but immediate assertion is very simple statements. Performance is low overhead, faster execution for immediate assertion, but in the concurrent assertion performance is high overhead, and then due to temporal tracking. So this is a difference between the immediate and the concurrent assertion. The main thing is immediate assertion is works for combinational logic, it works for simple logical checks, but concurrent assertion is mostly used for sequential logic. It is depends on clock, and then it is mostly used for protocol checking. Protocol checking is here. So protocol checking means protocol, the main thing of protocol is we know that protocol meaning it having some rules and regulation. Okay, this is a basic definition of protocol. Same like, so in the protocol if we having some lot of signals, lot of things, lot of logic is there. So to verify that you have to use concurrent assertion. Okay, so and then we'll see into syntax for the immediate assertion. So this is syntax for immediate assertion. Okay, So I will show you the code, then only you can understand. The main thing is of syntax is assert, boolean expression, pass statement, else, fail statement. It is basic. It looks like a if else condition only. If it is true, it will execute this, or else it will execute these fail statements, else condition. Same thing. Assert is keyword. So here we have 5 value means it will execute these fail statements. Okay. So this is example for the immediate assertion. So here you can see the always combination block. This one always combination block. Here this is a name of the asset, like a mutx underscore check. This is the name of the asset, assertion. So this is a assertion keyword. So this is a expression. This expression means enable 1, en is enable 1 and then enable 2. So both are must be low, then only if both are low means like if it is 0 0 0 0 means logical 0. If it is 0 1, if it is 0 means this asset will get true condition, so it won't display anything. If it is having 1 means it will display the error statements. So error like a dollar display, dollar monitor, we have in the error in the SystemVerilog assertion, dollar error, dollar fatal error, dollar warning. So these are the display statements we can see in the transcript window. So it will display these error statements, mutual exclusion violated. So and then you can see here, well, FIFO, we know that FIFO is kind of buffer, first in first out. So assertion FIFO count is less than or equal to FIFO depth. If it is true means it won't display anything. If it is if it is false means it will execute this fatal error, FIFO overflow at count D and the FIFO count. So this is a basic checking of basic usage of assertion. So we can check the logic. So this is, you can see here, these are the severity levels. Severity level is nothing but it is mostly used for displaying some warning messages in the transcript for assertion. Dollar fatal, dollar error, and then dollar warning. So dollar info. This is some system task severities in the SystemVerilog. Okay, so let's see the one example, then only you can easily understand before going to the concurrent assertion. For example, this is example output waveform window. So you can see here assert, this is my condition, assert a double ampersand symbol. This is like a logical and b, a logical and b. It means at some time a and b must be high. Okay, then only our assertion will pass. If it is a having 0, b having 0 means it will give the fail assertion. Okay, at the same time a must be high, a signal must be high, and also b signal must be high. Okay, then only our assertion will pass. So you can see here in the first passage a having high, and also this is a signal, this is a b signal waveform, a having high, b having high, so both are high. So this assert condition, this assert expression is passed. So pass means it is this is what we need, this assertion need. So a having high, b having high, so one ampersand double, like a one logical and of 1 means you will get the high. So both are high means, so our assertion will pass. We can see here pass will be, you can see here assertion passed. Here in the second passage a having 1 but b having 0, here assertion failed. So here also you can see here in this passage a having 1, b having 1, so both are having 1, so logical 1, so you will, the assertion will pass. So this is how it works. So this is our assertion, this is our condition, this is our expression. If it is satisfied means assertion is passed. If it is not satisfied means assertion will give the error message or it will fail. Okay, this is how assertion is working. So this is how we can use this assertion in our logic, in our design code. So we are mostly using some logic in our design code. Like you will need some for certain time of design code, you have this condition. So a signal, b signal must be high, so then only you will get the assertion pass, then only you will get the correct output. So on the time how you can verify means by using this assertion writing you can verify that your design code. So let's see one code. So this is a code. So you can see here module assertion. This is my module name. This is my internal signal bit clock A and B. So this is my like a this is my internal signals, okay. So this is my clock creation. We already know that always at every 5 nanoseconds, based on our time unit, it will execute. So based on the 5 nanoseconds, so at every 5 nanosecond our clock will be toggling, okay. So clock equal to not of clock, it will do toggling. So I'm creating the clock. So and then here I'm giving the input value for A having 1, B having 1, okay. So after 15 nanoseconds, this is my simulation time. So initial begin is my simulation time, okay. A having 1, B having 1. So initially at the starting stage of stimulation, A value. So this is my signal A B clock. So clock signal is used for creating clock. So I'm creating the clock here, clock generation. So A having 1, B having 1. So at the initial stage of stimulation, after 15 nanosecond, I'm changing my stimulus. I'm changing my input. B having 0, B having 1, and then A having 0, A having 1. After that some delays, okay. With respect to delays, I'm changing my stimulus. So here I am writing the assertion. I'm writing the immediate assertion, okay. Here always, this is always at passage of clock. This assertion will looks always it will work based on the passage of clock. So at every passage of clock, this assertion will work. It will check, it will seeing this condition. At every passage of clock it will works, okay. So at assert A and B, A logical and B, it means at the passage of clock A signal, B signal must be high. If it is high means it won't display anything. So our assertion is passed. If it is any having low, it means A having high, B having low, means you will get the logical low. So you will get the error message. So you can see here, this is a basic assertion. This is a basic immediate assertion. My input, this is my stimulus, this is my inputs. You can see here at the initial stage of time, A having 0, sorry, A having 1, B having 1, okay. So let's check the output. You can see here assertion. You can see here assertion. This is my assertion name. You can see here assert underscore 1 has failed, assert underscore 1 has failed, assert underscore 1 has failed. So here I'm getting the assertion failed. Why? Because of on the time of clock. Why? Because of I didn't give any clock input for my simulation. So that's why I'm getting the failed value. If I change into clock 1 here, this is my at the passage of clock, like after 10 nanosecond my clock will be toggling. So this is my input of my clock. Why? Because of I'm just toggling the clock here, but I didn't give any input for the clock. I given like a only value for A and B. Only I'm giving stimulus for A and B, but I didn't give any value for clock. This is how assertion we can say here, I didn't display any failed statement. We can see here assertion dot underscore ex. This is my module name. So we can see here under assertion underscore ex, this is my module name as failed. So in my module assertion underscore ex, what I written for assertion, it is failed, okay. So let's see the waveform window to see the output. So you have to click open EEP waveform and then save and run again. So you can see the attendance link for day 13. So just fill the attendance link. So this is how we can write the assertion for immediate assertion. So we can this is how we can use assertion for checking the logic. So let's wait for few minutes, it is loading. So here I'm changing into my A having 1, B having 1. Always I'm having the A and 1 value high. Okay. I'm always having the A equal to 1, B equal to 1. Okay. So let's check the output. So you can see here I didn't receive any assertion failed message. Why? Because of I am always giving A equal to 1, B equal to 1. So this is my assertion. So this is my logic. Always A must be having 1 and A having 1, B having 1. If it is having 1 means our assertion is passed. That's why I didn't receive any error message. If I change any value like A equals 0, B equals 0, I will receive the error message from assertion. So I didn't return any error message, dollar error, dollar fatal error. So I didn't any message dollar display statements, but it will give the output as error. So you can see now. So you can see here assertion failed, assertion error. You can see this. You can see here assertion error. Why it is happening means my assertion logic is failed here, then that's why it is displaying the assertion error. Okay, so this is how we can write the immediate assertion for my logic. So it is very simple logic. While entering into protocol you will get more logic, so you have to verify that. So you by using this method you can easily verify that. Okay, this is like this is only for this is an example for the immediate assertion. Let's move into the concurrent assertion. Okay, so concurrent assertion is mostly used for the sequential logic. It having, so here we have to use boolean layer, sequence layer, property layer and assertion layer. So in the expression, so in the boolean layer you can write these kind of things like by using the logical AND operation, by using the dollar rows, dollar stable. These are the keywords in SystemVerilog assertion. We having the lot of keywords in SystemVerilog assertion, dollar rows, dollar stable, and then this like a implication operator. So this is a #1 means it is defining the clock cycle. Okay, so it is also defining the clock cycle, and then it is also implication operator. It's a non-overlapping implication operator, and then non-overlapping implication operator. So there are a lot of operators in the system, like we'll see one by one. So how to use. So this is a basic logic. This is a basic expression we are going to use in this concurrent assertion. Dollar rows must means this start is kind of one signal. If it is it must be always having 0. So dollar rows is defining as changing from 1 to 0. If it is having 0 means that particular signal, if it is having 0 means whether we can say that my assertion is passed. Okay, dollar stable, this is one signal. This is syntax for the boolean layer. So dollar stable is a keyword, data is a signal name. So here is a start is a signal name. So if I'm using the dollar stable means that particular signal must have in the stable data from current passage and also previous passage, from two passage like a previous passage and also current passage. If for 2 clock cycle the data signal must be having the value, the stable value. So it won't change anything, 0 to 1, 1 to 0, or any 5 to 10, 10 to y. For example, data having the 5 value, previous clock cycle must be 5 and then current clock cycle must be 5. If both clock cycle are having the 5 value for the data means, so it won't display any error message. If it is change value 5 to 10 or 5 to 6, it is changing means it will display error messages if you are using the dollar stable keyword. So there are a lot of control, a lot of keywords is there, like a dollar rows, dollar stable, dollar fill, and then this operator, and then implication operator, non-overlapping implication, and then asset property. So there are a lot of topic is there. So let's see one by one as soon as possible. So and then let's move into PPT here. So this is how concurrent assertion is working. So firstly we have to create the boolean expression, and then we have to create the sequence was kind of the block, like a class itself. So like a class it is same, like it's having syntax: sequence, end sequence, property, end property. Okay, and then asset. So firstly we have to create the expression, boolean expression, it is main logic. Then you have to create the sequence. Inside the sequence you can create a number of expression logics for your signal, and then inside the property you can call the sequence. Okay, so if you want to access the property, means we have to assert the property. So this is happening inside your initial begin block, inside your simulation. Okay, so firstly you having sequence. Inside the sequence you have to write some logics, you have to write some assertion for your logic, and then that sequencer are called inside your property. So this is a property, one kind of block. Inside the property you can write the logic, or else you can call the sequences, whether for if you created the sequence before, means you can call the sequence inside your property. So and then property is a final, and then in your simulation time, like initial begin time, you have to call the property, you have to assert the property, then only it will execute, it will trigger. So we have to call the property inside our initial begin block, inside our simulation block. Okay, so and then boolean expression. So we'll see some definition for boolean expression. The functionality is represented by the combination of multiple logic events. These events could be simple or boolean expression. So this is basic expression. The name itself having the boolean expression, it means you will get the you will give the logics for your verification. Okay, so and then sequence. So this is a sequence, looks like syntax: sequence name, and then end sequence. This is a syntax for the sequence. So inside your sequence you can create the a number of boolean expressions. Okay, you can create the logics. So it having some, it will give you can use a dollar rows, dollar fill, dollar stable inside your sequence. Okay, so and then property. So property is one kind of block. The block look like this only: property name, and then end property. So inside the property you can call the sequence, or else you can also write the expression. You can also write the logic for your verification. Okay, inside the property you can write the expression, and also you can call the sequences. Inside the sequence there is also expression. So here in the property also you can write the expressions. Okay, so asset is a main keyword. So this is a property is one that is verified during simulation. It has to be asserted to take effect during a simulation. It means, so asset is a main keyword. You can see here asset underscore property. Here also give the property name. So in the bracket you have to give the property name. So what you are given in this property name, you have to give in this property, like inside the property, inside the bracket you have to give the property name. Then only it will assert that property. Okay, so main thing is inside the sequence we are writing logics, expressions. So inside the property we can call the sequences, and also we can write the expressions inside the property. To if you want to execute this property in your simulation, means you have to use asset keyword as a main keyword, asset underscore property. Then here you have to write the property name. If you write that particular property name, means it will assert the property, it will execute that property in the simulation time. Okay, this is a basic information about concurrent assertion. So in the immediate assertions we can use only assert keyword. We can check the as soon as results, but here we have to write the sequence property, then only you will get the results. Okay, so we'll see one code for a concurrent assertion. Okay, so you can see here, this is my example. This is my module name, assertion example. This is my signals, internal signals, clock and A. Clock for creating the clock generation. A is my signal. So data type is bit. It means it can capable to do performance with only one bit. Okay, it may be high or low. So in here you can see here clock creation. So at every 5 nanoseconds I'm toggling my clock, and also this is my stimulation. This is my simulation time. So at a initial state A equal to 1, it means I'm assigning A equal to 1. After that, after 15 nanoseconds I'm assigning A equal 0. After 10 nanoseconds I'm assigning the A equal to 1. After 10 nanoseconds I'm assigning A equal 0. After 10 nanoseconds I'm assigning the A equal to 1, and then I will finish my simulation after this time delays. Okay, I am writing assertion like assertion sequence. This is syntax for the sequence name, and then end sequence. This is syntax. Inside the sequence we can write the expressions, and also we can use the clock. The main difference between the immediate assertion and the concurrent assertion is, in the immediate assertion you can't use the clock. Okay, but in the concurrent assertion you can use the clock. Okay, that's how we can use. That's why I'm using here at passage of clock. So at the passage of clock, A having 1, A equal to 1 means the A signal must be high. Okay, this is a logic for sequence 1. So you can create a number of sequence. Okay, so and then this is my assertion property name, assert property. This is my assertion property, and then I'm calling my sequence name here inside my property. Assert is a main keyword, and then property here. So we can also create a property, any property, but we can use also like this, property and then sequence name, sequence underscore 1. So this means I am asserting my sequence 1. So let's check the output. So I will use the Costasim as a tool. You can see here assertion failed. You can see the error message. Why? Because of I didn't create any clock input. So here I am giving the clock equal to, or else I can give also here A equal to 1. So it means by default A signal having 1. Okay, my logic is I'm checking here in the sequence I have at the passage of clock A equal to 1. Okay, so I need to create the clock here. So how we can create means I have to give the clock input. So we can also give here clock equal to 1. Okay, so initially clock having 1, and then here not of clock means not of 1, 0 will assign to the clock, and then that 0 will assign comes over here, and then not of 0 1, and then 1 assigned to the clock, the signal, and then 1 comes over here. That's why this is how it's working. So at the 25th nanoseconds, so 15 25th, so you can see here at the 20th nanoseconds, 20 nanoseconds like here 15, like initially A having at the starting stage of simulation. At the starting stage means this is my starting stage, A having 1. Okay, and the time here you can see the time, you can at the time nanosecond is 20 nanoseconds. At the 20 nanosecond only I am receiving the error messages. before the 20 nanoseconds, like at 19 nanosecond or 10 nanosecond, I didn't receive any error message. Why? Because of on that time my clock, my signal here having 1. That's why I didn't receive any error messages. So here, so 15 after the 15 nanoseconds only I am getting the error messages. Why? Because of it will take 5 nanoseconds to toggle, and then plus 5 nanoseconds, total 20 nanosecond. At the 20th nanoseconds I am having the input value of a equal to 0. So but I need a equal to 1. That's why it's showing error, a having 0, assertion failed. It's showing the output like assertion error at the 20th nanoseconds. Okay, so this is how it is work. This is how concurrent assertion is working. This is how we can check the design code, we can check the logic. So and then we'll move to the another code. So this is refers to this as is refers to a must be high, like this line is refers to a must be high if a equal to 1 after 2 nanoseconds, after 2 clock cycles. This as 2 is refers to 2 clock cycles. If you are giving means after 2 clock cycles, when it is after 2 clock cycle means if a having 1, if a having 1 after 2 cycle, after 2 clock cycle, B signal must be high. Okay, this is the meaning of this line. So at passage of clock, it will check at every passage of clock after the a, if the a having high, if the a having the 1 value high means if having a having high, after the high of a after 2 clock cycle, if a having 1 means after 2 clock cycle B must be high. If it is not B must be high means it will, our assertion is failed, it will throw an error. So this is my logic, this is my sequence. So we know that inside the sequence you can write the expressions logics by using the clock. Okay, so this is my first logic. Okay, so I am calling this inside my property. So properties of sequence, asset property. The main thing is a having, if the a having high, after the 2 clock cycle B must be having high, then only it will give the output, or else it will give the assertion failed output or assertion error output. Okay, so let's see the output. This is how we can check the results. So it is mostly important for only verification. So you can see here assertion failed all the time. Why? Because of if I give like a equal to 1, I didn't create any signal for clock. So attendance, day 2 attendance you can see in the chat box. Please fill the attendance. So you can see here. So I will change my simulator to Custasim. So you can see here at the 20th nanosecond, this is my module name, and then at the 24 line assertion failed. Why? Because of, so I didn't write in correct value, correct condition, I didn't pass my stimulus correctly inside my initial begin. That's why I'm getting the assertion error. So I didn't written any assertion error statements inside my code, but I'm getting that statement as a output. So how it is happening means, so I'm assertion, my stimulus is not suit with my logic what I written in my assertion. Okay, so and then let's see the another code. So this is how we can create the sequence and properties. So this is my another example code. Here I am having the three inputs, clock A and B. Then this is my simulation time. Here I am giving the inputs for my clock and signals. This is my clock signal having 1 at the initial stage. After the 10 nanoseconds, after the 5 nanoseconds, I can say like a 10 nanoseconds. Okay, this is my stimulus at the initial stage of stimulus, clock having 1. After 10 nanoseconds, A having 1, B having 1. After 15 nanoseconds, A having 0, B having 0. This is my stimulus. So this is my assertion writing. So here you can see the sequence. So inside the sequence you can write the logic. So this refers to A signal having high. If the A signal having high means after the 2 clock cycle, B must be high. Okay. So inside my property, this is my property syntax, property name. So you can see here I am using the clock at passage of clock. It will check at every passage of clock. Okay, you can see here not. So not means if it is not happening, so if it is not working, so if it is true means here, if it is happening means, so if I didn't receive, so if I didn't write any not means I am calling this sequence inside my property. Okay, but I am using here not. It means not of this sequence. If a not of sequence is happening means this happening means our assertion is passed. If not of sequence is not happening means our assertion is failed. Okay, so I am here, you can see here I am assigning my assert property P. Assert, this is a keyword, and then I am asserting the property of P. Here I am writing the property name. So inside that property I am having some logic. So what some logic means, I am checking the not sequence. So if it is sequence is happening means I am getting the error message. If it is not happening means I didn't get any error message. Okay. This is so basic information about assertion. So while if you are studying freshly, this assertion means it's very difficult to understand, and then you have to practice. And then you have to read the assertion book. So there is a separate book for assertion. I will show you that. So SystemVerilog. So you will get the book, SystemVerilog book, like SystemVerilog Assertion 4th edition. So you have to read this book. So there are a lot of books in available free. So I think this one. Or else you can type PDF. So Accelera, so you try to follow the Accelera book. So this Accelera book, like this is a PPT kind of thing, but you will get the book over here. So if you are following the book means you can easily understand. So they will give a lot of examples. So this is how you can read the SystemVerilog very easily. So and then you can see here I am calling this assertion. I am receiving the error. Why? Because of I am giving the input like that. So in the first passage, so 0 1, so I am getting the output correctly. So that's why it is showing the error message, assertion error. This is how we can check the outputs. We can check our logic by using the assertion. So so this is how we can use assertion over for the checking our logic. So in the upcoming classes or else tomorrow we are gonna see the UART protocol. So UART protocol having some condition, so we will check that condition while using the assertion. Okay, so this is for today. If you guys any doubt means you can ask now. So and then day 12, day 13 attendance link already posted in the chat box, you can use that, you can fill your attendance. So it is also complex topic of assertion, so some people won't understand directly, so you have to spend some time to understand this assertion, so why it is used for. Before going to that, you have to have the knowledge about hardware, then only you can understand this. And then you have to knowledge about your design. So what is your design code? So I'm telling always design code means, so we know that after we know that full adder, half adder, so it is very simple design code. While entering the protocol, UART protocol, memory, RAM, FIFO buffer, and then AXI, so processor core, and then CPU core. So there are a lot of logics, a lot of design code is that complex design code, that while dealing with that complex design code, you will have the lot of logic kind of thing, like this: A and B, A must be high after the 1 clock cycle, or else B must be high after the 1 clock cycle. Then only you will get the high speed performance. Why? Because of we are using the chips very high speed. Okay, we are that whole chips, like our mobile phone chips, like SoCs, are works based on the clock only. If the clock frequency is high, means you will get the high speed execution. Okay, so we have to optimize the clock frequency. We have to essentially use the clock pulses as like a very fastly. So we don't have to use the clock pulses. So each and every clock pulse is important. Each and every clock pulses from the crystal is important. So at every passage of clock only, our systems is working. Okay, so if you click one button, means it will depends on the clock pulses only. So that's how it is very important. So clock pulses very important. So so we don't waste our clock pulses. So we have to optimize our clock pulses very highly, then only you will get the high speed execution, high speed performance chips. So we need to verify that. So how you can verify means, by using this kind of concurrent assertion only, you can verify your logic in the code itself. Then only you can implement in your physical hardware, physical transistor, physical chip. So firstly we have to verify the logic code itself, and then we will move into physical chip making. So that this is how it is important. Okay, so if you have any doubt, means you can ask now. So thank you guys, thank you for listening. So we'll see tomorrow UART protocol. So and then UART protocol, and then you guys are little bit refer the UART protocol. What is the frame forward? What is the start bit? What is the stop bit? So what is the data bit of UART protocol? So where we are using UART protocol? For I will give one hint. So you are I think most of people are aware of the Arduino cable. So Arduino board. This is one microcontroller Arduino. So you are having some Arduino cable to dump the code into memory, or the flash the Arduino board, means we have to use the code like that wire, like a Arduino cable. It is like a UART to USB protocol. So that cable works based on the USB, but the Arduino board, in the Arduino board, it having one IC. Okay, that IC is particularly converting the USB to UART. Okay, it will do performance of USB to UART. Why? Because of we are connecting the cable in our computer with the USB port. Okay, but inside in the Arduino there is no functionalities of USB, but it having the UART functionalities, UART protocol. So we have to convert the USB to UART protocol. From the by using the UART protocol only, so we will see we are seeing some serial monitor output. Okay, in the Arduino we are seeing some output like a serial monitor. We are giving some baud rate 9600 and then 11500. So these are the baud rates. We are using the UART, we are using in the Arduino IDE. So it is very important protocol and also basic protocol. So please try to refer the UART protocol. So and then we'll see tomorrow. Thank you guys, thank you for your listening.